Hi, I'm Gabe, and welcome to the world premiere public announcement for the extensions that I'm working on for the IPython Notebook. I've been working on 3 new cell types that I think can add something to the core notebook application that I think can be helpful for certain people. First of all, before I get into any of that, big thank you to the IPython Notebook core development team. Without all of their hard work, my extensions obviously would not be possible, and even without extension, they've created a really great and useful program, and so they should be very proud of that. So I've developed, or I am developing 3 new cell types. The first one is the interactive code cell. So here we have a notebook with some R code in it that fits a kernel regression estimator for some data that's just shifts with R. It has to do with cars, but that's not particularly important. The important thing is that this is a relatively standard IPython notebook code cell, but it has this extra slider attached to it, and by dragging the slider, we can actually control the code that's in the cell and thus the output that's generated. And so this is the interactive code cell type that I have been working on. One of the key features here, unlike some of the other approaches for interactive elements within notebooks, is that the code is actually the code that you run to get the plot. There's no code here that's generating the slider, and I think that is relatively important for certain applications such as publishing, because when you're publishing about code, you want the code that you're publishing to actually be the code that generates the output. You don't necessarily want a bunch of extra stuff in there. And so that is the interactive code cell type you can see up here. So how do you create an interactive code cell? Well, you take a regular code cell. Don't worry about that. That will go away. These are all very early days, so there will be some hiccups. But that's what research is all about, right? So we've got a code cell. This is just a normal code cell, nothing special about this at all. And we can change it to an interactive code cell, and it will pop up this window, and we tell it what variable we want to control. In this case, that's BW. The line number of the assignment that we want to override. So this is a little kludgy, and it'll probably be a bit different later, but for now, you just give it the line number, and it's going to clobber that line every time you use the slider. And it starts at 0, so that's at 1. Currently, you can only do sliders. More control types will come later. And then you got the attributes that are necessary for the slider. So minimum of 3, maximum of 45, and step 3. And there you go. Now you have turned your code cell into an interactive code cell. That's all there is to it for that one. So yeah, that's the interactive code cell. So now on to the ones that are a little bit more complicated. These are cells that can contain other cells. And so what I'm calling these are task cells and alternate set cells and alternate cells. And so task cells are basically just groups of other cells that you can execute with as a group. And so here we've got a very, very basic analysis of some housing data from housing sales in the Bay Area from 2003 to 2006. Again, I'm going to use R code. I'm a statistician. I know you Python guys are probably annoyed, but R Python doesn't really matter, right? So we are we've got 3 tasks essentially, and these are these sort of teal, turquoise, large boxes. We've got the reading data task, we've got the cleaning data task, and then we've got the plot task. And you can see here that you can actually run. Well, it's a little hard to see, but you can actually run the whole thing. So if I actually change this here to just print 2, and then we select the whole task and we run that, you can see that this output was updated. So when you run the task, all of its contents are run. So that is nice. That sort of allows you to organize your code and the descriptions of your code into executable chunks, which can be pretty useful. But much more useful is the alternate set cell, or the AltSet. That's these guys here. The blue one is the one that's currently selected or was most recently run. But you can see here that when we're cleaning the data, I have implemented a few choices that we have to make, right? So this one is whether we want to remove rows with missing values or not. So on the left, we remove all rows that have any missing values in it, and on the right, we do not. But the point of these alternate cells is that regardless of which one of these you do, the plotting code is the same, right? And so you can actually think of this as a sort of, it's a directed graph, but it comes back down to a single terminal point down here. And which path you take through these alternates will change the results that you get, but it's still part of the same analysis, right? The key thing, the key crux of this research that I'm doing that this is related to is that data analyses are not linear. You don't sit down, load your data, fit one model, make a plot, and then you're done, right? You do a bunch of things, you try a bunch of things out, and you see what works. But a lot of times the things that didn't work, or the things that sort of worked but you didn't end up using for your final report, are actually quite important in terms of the actual research that was done and the decision of which method you used. And so it would be good if our notebooks, our documents that describe the data analysis, actually contained that information. And with this type of setup, they can. And so we've got this run through here. We can run this. And we're running this, and then we come down here and we run that, and we get a plot, and that's great. And that is perhaps an informative plot, perhaps it's not an informative plot. But then we say, well, maybe we want to be a little bit more restrictive on the lot square footage, which is one of the two variables that we're using. So we switch over to there, we run it again, and now the plot looks very different, right? And so you can see here with some very easy combinatorics that there are 18 different possible paths through this, and each of those is going to give you a different plot, or a plot that looks different, but in essence it's the same plot, right? The same things are being plotted. It's just a question of what you did when you cleaned the data. And you could easily see that this could also be applied when you're choosing between two models, for example. I have another document that I'm not going to show right now because this is already getting a bit longer than I expected, where you're trying to predict binary data, and you just implement a linear regression and a logistic regression. And instead of only implementing one or the other, you actually implement both right next to each other, and that allows you to sort of see the consequences of choosing one over the other. And one of the major things that this buys us is that if you're a reviewer and you're handed a document like this, you're going to have a much easier time telling what exactly was done and whether due diligence was done and whether all the appropriate methods were tried, when compared to just being given a single sequential document. So this is all very nice. This is a pretty nice document, but how did I make it? I'm not going to go through how to make this whole big document, but I will show you how to make tasks and branches. And so to make a branch, to make a task, you just create this task right here. You just create a cell and convert its type to task. And then you can say, this is my task. Change that to Markdown. Run that. You can see when you run that, it adds a new cell under it, just like it does in a normal notebook, except it adds it within the task. And so this allows you to easily build up tasks quite quickly. And then we're going to say maybe this is just going to be very silly, but we're going to say X, I'm going to stick to R code because I can code it faster. I'm more familiar with it. R is equal to 1 to 10. My mistake. So you can see you can also insert cells above there, which is good. And that's great. And now we're going to create an alternative set that adds our two little things down here. The fact that they're small is a little bit annoying. They get bigger as you type, but that will be fixed in a future version. Also, the colors are probably pretty ugly. I'm not really very good about that. So that'll be fixed in another version as well. This is all very early days, first announcement and all that. So maybe over here we want to say plot X. But then maybe over here we want to say plot rev of X. And the spacing is not quite right. This should have gone over to the side, but it didn't. But that's fine. That'll be fixed. I'll fix that as soon as I'm done making this video. And you can see, though, up and down instead of side to side, unfortunately, but we have these two branches, and they represent two different things that you can do with this cell X. So there you have it. These are the new cell types that I have been working on. I'd love to hear what anybody thinks about this. The fork where these are implemented is available on my GitHub. My username is gmbecker. And also I'm a student at UC Davis, and so my email is also gmbecker at that school. So if you're not a robot, I'm sure you can figure out what that is, and I would love to hear from you. Thanks for listening, and hopefully we'll be able to talk about this and have some good conversations. Bye.